Problem 112, we will always start with our basic function y equals e to the x. Okay, that's e to the x. And then the opposite of e to the x would be flip that over the y-axis, sorry, the x-axis. So if we flip that over the x-axis, we have negative e to the x. And then we're going to take this negative e to the x and we're going to replace x with x plus 2. So when we replace x with x plus 2, that means we're going to be moving it to the left 2 units. So our key point would be right here at 0, negative 1, and when we move that key point to the left 2 units, we move the entire graph to the left 2 units. We still have the horizontal asymptote. Okay, and so that is e to the x, negative e to the x plus 2, and then all we have to do is take this graph and drop it down 1 unit. But when we drop it down 1 unit, we're going to end up with the asymptote, the horizontal asymptote, moving as well. And so I'm going to go ahead and just drop this down. First of all, I'm going to erase everything, but I'm going to remember that negative 2 is my key point. So I just dropped it down, and let me do this in a different color. Negative 2, dropped it down, but I want to put my horizontal asymptote, okay, because I had to drop that down as well, and then we just draw the graph right through our key point, and our key point again is negative 2. If you wanted to plug that in, if you wanted to, you could replace x up here in the equation with negative 2. That didn't show up very well. If we wanted to replace x with negative 2, we could see that we have negative e to the negative 2 plus 2 is 0, and then minus 1, and negative e to the 0 is negative 1, minus 1 is negative 2. So that's just a way to check to see, to make sure that our key point found its way to the right place. And then up above it says specify the domain. Well, the domain is all real numbers. Okay, that's all reals. The range is all real numbers less than negative 1, so that would be indicated by the interval from negative infinity to negative 1. Okay. Intercepts, we have no x-intercept, but we certainly have a y-intercept, and the y-intercept is pretty easy because we can just put it anywhere we want, but what y is equal to is when x is equal to 0. Okay, so that's easy because we can just replace x with 0. We get negative e squared minus 1. So I don't know where that is. I don't really care. All I know is that that is my y-intercept right there. Okay, and then asymptote. Well, the asymptote, we saw what that is, and that is y equals negative 1. And so there you go. I should probably put that in green and box that as well, so it's consistent. So not green yet. There we go. Green is now. Y equals negative 1 is our horizontal asymptote, so let's put the ha right there, and the ha would be the y equals negative 1, domain and range, asymptote, and y-intercept. Okay. Now these are the tougher ones. I'm going to go ahead and rewrite my y here. I'm going to write y equals negative, and then ln of negative. I'm going to factor out a negative from the inside. I'm going to get x minus 2, okay, plus 1. Now what happens is I'm going to go ahead and graph ln of x, and then negative ln of x, looks like that, okay, and then negative ln negative x is going to look like that. Okay, so this is negative ln of negative x, okay. That's what that is, the blue one. So let's erase the red and the green. Okay, so now we're down to y equals negative ln negative x. Now, if we replace, remember, if we replace x with x minus 2, it means that we're going to take this graph that we see here, and we're going to move it to the right 2 units. So our key point is at negative 1, 0, and if we move that to the right 1, 2 units, the key point moves there. Now ln has a vertical asymptote. So as it turns out, the vertical asymptote also moves to the right 2 units. Okay, the vertical asymptote was the y-axis for a while there, but now moving it to the right 2 units, the vertical asymptote is at x equals 2. Okay, so this graph right here, the red one, represents the function y equals negative ln of negative, I'm running out of room here, hold on. Okay, let's do it right down here. Y equals negative ln of negative x minus 2. That's a pretty tricky one. And then we just take this whole thing and we add 1 to it. If we add 1 to it, we're going to bump it up 1 unit. So let's do this. What color should we use? Let's use a green. And bumping it up 1 unit means that we're going to, our key point is going to go right there at 1, 1. Okay. And since I'm bumping it up 1 unit, I know my asymptote is at x equals 2. So there we go, right like that. Okay, so the green graph is the graph that you see here, bumped up 1 unit. And again, 1, 1 is our key point. And so let's just make sure that we check with our original function. When we replace x with 1, we get y equals, okay, so up here we have y equals negative ln 2 minus 1 is 1. Okay, ln of 1 is 0. And so this whole thing, when we replace x with 1, we get y equals 1. And so that checks out. That checks out that we actually, our key point is actually on the graph. And so you can double check that on your graphing calculators, and I hope I got it right, because I don't want to have to do this video again, but yeah, that's right. There you go, 1, 1. Check.